This is a problem that recently our friend Robert Kaplinski used, and he was curious how many of his students would try to get a numerical answer. I hope you're thinking about it a little bit. And it turned out that 75% of his 8th graders tried to give a numerical answer to this question, and all of his 6th graders did. And that's pretty consistent with research that's been done. When my husband had 5 kids, his 3rd grader was doing this problem, and he said, you know, I am the high school math teacher, that's not how you did it, and how you do this. And the kid said, my teacher said that's how you do it, so that's how you do it. I don't care that you're the high school math teacher. The only high school math teacher, by the way. Here's a comment on a blog I saw recently. This kid's son just said, Mom, you aren't supposed to think about math, you just do math, right? This is a situation that we are in here. About 10 years ago, working with some 3rd grade kids, this was a district assessment they did to see if they were all learning math. And of course, you could either add or multiply, because what's the difference, right? You just pick one. And in fact, more kids did add than multiplied. Here's another problem, the same later in the year, but the same sort of setup. And you know, okay, I got an 8, I got a 6, I don't know, they took the 2 best choices at least, right? But what happens in this very district where they're giving them problems like this? Here's how you solve math problems. It's so easy. You just cracking the math code. If you just pick out the right words, and then you'll know what operation to do with the numbers, right? And in case you missed the question that was a multiplication question in this same district, in all to them means add, so they added. Why wouldn't they, right? Here's another one that I just ran into recently, and I just have to say, you can get cute little posters of this on the internet, and I'm sure it's lovely and everything, but it's not about doing mathematics, right? Kids have this idea that that's what math is. You just do whatever you're told in whatever order seems to make sense because it's Tuesday, right? And it doesn't matter that none of it makes sense. That's okay. None of these kids had a problem with any of that, right? How old is the shepherd? He's this old, and I'll tell you why, right? So just last week, I did a talk about sense making, and this one teacher says, so I have them do the circle thing and then the pick the speaker words thing, and you're kind of telling me maybe I shouldn't do that. What do I do instead? And I said to her, well, what are some things that you do in literacy? I was in a class one day, a 6th grade class, and they read this book, which you should read if you haven't, and she took predictions from all the kids about how these 2 characters were related. And she said, great, I got all your predictions, we're going to come back tomorrow and find out. And I was like, this is a great teacher, right? She's letting them make predictions. 6 seconds later, they're doing math, and she's saying, no, you're wrong, no, you're wrong. Oh, you have the right answer, you're the good kid. What if we turn math into literacy? What if we ask them, instead of finding out how many roses you have, draw me a picture of the story, right? Kids are able to do that. Here are characteristics of strong readers. It doesn't take very much work for us to change this into characteristics of strong mathematicians. It's the same thing. These are things that we want our children to do in literacy and in mathematics, yet we're not doing them. Every kid, little kid, can tell you when they don't know a word, how do I figure it out? I sound it out, I look for context clues. In math strategies, what do you do when you don't know it? You skip it. Not true, okay? But they need to have explicit strategies when they don't know what to do in math, right? We teach these sorts of comprehension skills in reading and in literacy. My favorite one, because I want to tell you a story, is make a movie in your mind. My friend Debbie was talking with some of her 5th graders about this problem, and how many paper towels in the closet? Every one of you in this room just had this picture come up in your head. She was talking to her 5th graders, no picture at all. They're just looking at the numbers and going, I got to figure out how to know what to do with the numbers. They don't have a movie in their mind. This is our fault, by the way, just so you know, as a collective whole, all right? This is the first mathematical practice for a reason, right? If we don't do this one, as Grace said earlier, it doesn't matter. The rest of them don't matter. If we're not doing this, our children are not going to learn mathematics, right? So how do we encourage sense making in the classroom? Get rid of the questions, for one. Here's a couple situations. I want my 1st graders and my 2nd graders and my 4th graders to be able to think about these things and to come up with mathematics that are important to solving these. And maybe I'll ask them a question, or maybe they'll answer them all. Here's a version you can do in high school. What sense do you make out of this? The book that goes with this, they tell you what you should notice and wonder about this. Get rid of that. Let the kids do the noticing and wondering. Let the math come from them. Here are some other ways to encourage sense making. Here are questions to ask. Don't ask, who's got the answer to number 7? Ask them about their ideas. Ask them about their decisions. Ask them about things that they talked about. What questions do you ask in math? Record yourself with your phone and listen later, right? You'll know, am I asking sense-making questions or not? I implore you, stop cracking the math code, right? Make sense-making a focus of every single thing you do in your math classroom. Thank you.